found there. Today's webinar focuses on the challenge of scaling post-harvest innovations, and we'll hear from innovators who have successfully developed and scaled post-harvest technologies. Our first speaker for today is Dr. Mohammed Monjurul Alam, Professor of Farm Power and Machinery at the Bangladesh Agricultural University and Director of the Post-Harvest Loss Reduction Lab at that university. He'll be speaking on scaling the locally manufactured BAU-STR grain dryer in Bangladesh. The second speaker will be Dr. Kerry Clark, who's a research professor and director of international programs at the College of Agriculture, Food, and Natural Resources at the University of Missouri. She'll be speaking on scaling the Soybean Innovation Lab multi-crop thresher. We had hoped to hear from Mr. Isaac Sesi, the CEO and head of product development at Sesi Technologies, Ghana this morning. Unfortunately, a few minutes ago, we received a message from Isaac Sesi that he was in hospital in Senegal, feeling ill. We are thinking of him and hoping the best for him, and regrettably, he will not be with us today, but we certainly hope for a speedy recovery and that he may join in a later webinar. More details on each of our speakers and their bios are in the web box and attached, so you can read more of them. I will not be doing justice in the introductions, I'm afraid, but hope that you can take time to read about them. It's really our intention in this webinar series to be both substantive and interactive. In the interest of substance, I'm keeping my remarks very brief and asking you to read the very impressive bios yourselves. In order to make the event interactive, we've asked the speakers to be very targeted in their remarks and keep to time. And we ask that participants engage in the chat box with questions and comments, and in particular, use the Jamboard, which will gather input from the listeners that will be used as fodder for the discussion later with the presenters. So to facilitate that process of using the Jamboard, I'm going to turn the mic over to Maria Jones, the Associate Director of ADMI, to introduce you to how to use the Jamboard. Maria?
Thank you, Alex. Hello, everybody, and welcome to this wonderful webinar. I want to very briefly show you a tool that we're going to be using today called the Google Jamboard. Each of you should be able to see a link in the chat box right now that my colleague Sarah has shared that links us to this Jamboard. A Jamboard, for the lack of a better word, is just an online whiteboard. And what I'd like there are 3 questions in the Jamboard today. The first question is, please share examples of post-harvest technologies that you have seen successfully scaled up. As you can see my cursor out here on top, there are the second question, the second board is what can be done to further scale and sustain adoption. And the third question is, what's your advice for entrepreneurs as they seek investment to grow their post-harvest business? We are addressing both continents, Sub-Saharan Africa and South Asia. We also have the 3 technologies today with the BAU-STR dryer, the multi-crop thresher, and if we hear from Isaac Sesi, the GrainMate moisture meter. And just to give you a quick demonstration, to your left, right now where my cursor is, you have a sticky note. For example, in this question of sharing an example of pH technologies that I've seen scaled up, I am putting the PICS bags from Purdue, which are hermetic bags. So as you can see, it throws up a sticky note. So I would encourage you to, over the course of this presentation today, as you hear from different speakers, to engage via the Jamboard. We will have a time towards the end of the webinar to hear what you participants have said and the advice you're giving our speakers as well. Thank you, Alex.
All right. Thank you, Maria. And now it's my great pleasure to invite Professor Monjurul Alam to discuss his experience with scaling the locally manufactured BAU-STR grain dryer in Bangladesh. I know I just promised to keep my comments short, but I have to acknowledge that I've worked on many projects with Professor Alam, and his contributions have always been instrumental in all of the many teams with which I've interacted with him. So Professor Alam, the mic is yours.
Thank you, Professor Alex. I'm going to just share my good morning and good afternoon and good evening, wherever it is suitable. So distinguished participants, ladies and gentlemen, this is Monjurul Alam, as Professor Alex introduced me, and I'm the principal investigator of Philae Bangladesh, and professor at Bangladesh Agriculture University. Welcome you all to my presentation on scaling locally manufactured BAU-STR grain dryer in Bangladesh. In today's talk, I will be limited to speaking on filial Bangladesh intervention in drying of paddy and development pathway of BAU-STR dryer, concern at the development stages of BAU-STR dryer, and concerns at scaling stages of BAU-STR dryer. So dear viewer, as you know, the Bangladesh is a developing country, and Bangladesh agriculture in recent past, it was totally traditional and manual, especially in the case of rice harvesting. So it was traditional and depending on human muscle power. Just recent years, combined harvester has been introduced in Bangladesh agriculture for harvesting. So after harvesting,
you've muted yourself.
yeah, sorry.
Dr. Alam, it looks like you're back on mute for some reason.
Is it all right now?
Yes, now it's fine.
I don't know what happened. Let me see what happened.
We can hear you now. We can hear you now.
Yeah. So that's great. So as I was talking, that 80% of the total paddy production, and that is 44.32 million tons, that is usually being dried on mud floor or concrete floor under the open sunshine. And the process is weather dependent. And from our study, what we have seen, the drying loss at this stage is about 3.5%. And that amounts 1.55 million tons per year. So filial Bangladesh tried to introduce and develop a dryer particularly for the farmers level as well as the seed traders level. The dryer is called BAU-STR dryer. Particularly this BAU-STR dryer, the drying loss is almost negligible, and it could potentially save about 1.3 million tons per year. The dryer also saves money during operation, saves time, and saves labor. And it returns hard cash to the farmers and the small traders. Let me introduce you with the BAU-STR dryer. It is a bin-in-bin batch dryer. Capacity of the dryer is around 500 kg per batch. And it usually takes 45 hours to dry from 23 to 25% moisture content to 12% moisture content. We have two heating options. One is liquid petroleum gas, another is rice husk briquette. The production cost.
See the slideshow.
It is already in slideshow. So can you see the Chayan?
No, not really.
We can see the slides, but they're not moving. I don't think you're in slideshow.
Okay, I don't know. I haven't ended, but I don't know what is happening. Can you see now,
Okay.
please?
Yes, we saw it move. You're not in slideshow. But yes, we saw it move.
Is it in slideshow now, please? I have already put in the slideshow.
No, but if you would like, would you like me to share my screen, Dr. Alam?
I think it is better, Maria, to share it. Okay.
Yes, I will share it, and you're on slide
I
number.
will stop sharing. Yeah.
Just give me one moment.
Thank you for your patience with the technical difficulties to Prof. Alam and the
Yeah.
audience.
Sorry.
No, it's a miracle
Just
that we can
previous
do this at all.
previous one. Just previous one. And next, please. Next, please. Okay, next, please. There is another show. You are actually saying me the, yeah. I know that, and the operating cost of the drying in liquid petroleum-based, gas-based dryer heating system is 0.93 taka per kg. And when it is dried with a rice briquette-based heating system, the operating cost is 0.78 taka per kg. On the contrary, the sun drying cost about 2 taka per kg. And the payback period of this dryer is less than 1 year. And the dryer can save up to 3% over the sun drying. You can have a look of this video. So our video through this link is given below in Bangla and English. Previous slide, please. Yeah. Let me talk about the development pathway of BAU-STR dryer. As you see that in 2011, we actually had a market study. And we have identified through that study that a Vietnamese dryer called STR dryer that can be suitable in Bangladesh. And it is imported from Vietnam to dry the maize. And at this stage, we actually introduced rice briquette system for the heating system. And in 2014, we tested the dryer, STR dryer for the paddy. And when we have started this Tilil Bangladesh program in 2015, we have tested this STR dryer vigorously, and we have made some changes on this, this inner and outer bin of the bamboo mat bins are replaced with a MS wire mesh bin. A generator was introduced where grid electricity was available, and a temperature monitor was also introduced to see how the temperature of the dry air, hot air actually going into the dryer. So during 2016 to 2018, we have again made some changes. That is, we introduced the SS wire mesh in a state of MS wire mesh, and we have actually developed and construct this temperature monitor ourselves and introduce it. And the dryer was tested on different varieties in different regions, and it is demonstrated to the farmers and the local service providers and farmer school. During 2019, we have actually introduced this blower. Initially, it is imported from Vietnam, but then we have manufactured it locally with locally available materials, and we introduced LPG-based heating system. And this modified dryer was tested and compared with the previous version. During 2020 to onward, scaling was taken place, and more than 200 dryers are adopted at farmers level and farmers groups and seed traders level. Next, please. Next, please. So let me actually talk about the concerns at the development stages of BAU-STR dryer. As you know, there are few issues. Initially, the blower that actually provided the hot air to the bin, it was imported from Vietnam, and it cost about USD 447, and the supply chain was uncertain. So later, we have actually manufactured this blower in Bangladesh condition, and the cost reduces to $294. And now it is easy to repair and maintain this blower. As you know, initially we introduced the rice briquette as a heating system, but it was unavailable in some areas of Bangladesh, and it needs frequent feeding into the dryer. So we have actually introduced this LPG-based heating system, and that is available locally, and heat is controlled easily, and it is less supervision is needed. Initially, when it is imported, that was the bamboo mat, that was the inner and outer bin, that was weak and short life, and that was replaced, as we already mentioned, that MS sheet and then SS sheet. Now it is stronger and the long life. Initially, we imported the actually temperature monitor. Later, we have produces, design it locally, and actually manufacture it locally. And now it makes the alert beeping above the set temperature. Next, please. Now I like to talk about the concern of the scaling stages of BAU-STR dryer. As you know, Bangladesh is a developing country, and almost 48.38% of the farmholds are small and marginal. And the farm size is very small. It is only 0.6 hectare. And the paddy production of the farm size is only 1.6 tons. So the smallholder farmers, they face the problem, especially during the scaling, that is the individual farmer cannot utilize full capacity of the dryer, as well as the purchase price is burden for individual farmers. So we came up with a solution of, that is local service provider. In Bangladesh, that is one of the model is working for agricultural machinery services. So a micro entrepreneur, he owned the machine and provided the service to the farmers on rental basis. So they can use the capacity as well as the farmers group, they can arrange the money and they can utilize the full capacity of the dryer. And there is a government policy to provide 50 to 70% subsidy on this dryer. In the next 5 years, so 5,000 of this dryer will be disseminated through this subsidy program. Another problem during scaling we face that the marketing and after-sale services. This is really a big issue, the market of the whole country. So we come up with a solution. We had a tri-party agreement between this project, that is Bangladesh Agricultural University, and the ADI, Agromac Development Initiative, and ACI Motors, the largest machinery marketing company in Bangladesh. So now the ACI is in charge of actually marketing and providing the after-sale services to all over the country. And ADI is actually looking the manufacturing side, and BAU is actually looking the quality issues of this manufacturing as well as the after-sale service issues. So far, the Department of Agricultural Extension actually disseminated 180 BAU-STR dryer to farmers groups, and there are about 5,000 actually dryer that is being provided to the farmers through this government subsidy program, as I already mentioned. That is 50% to 70% subsidy is provided. And FAO MMI project, they actually promoted 5 years, and individual farmers and lead farmers and the seed traders, they actually bought around 16 of them. So far, more than 200 dryers at the field, and we actually communicated with them and having the feedback. Then the capacity building is one of the main issue, and especially when an entrepreneur or particularly a person who is operating the dryer, few things are really important and need the capacity building. And we have now collaboration with the Department of Agricultural Extension, that is the largest actually extension and dissemination institution in Bangladesh, ACI Motors, the largest actually agricultural machinery company, and then Jagarani Chakra Foundation, that is one of the NGOs. And we have organized, the youth network, that is a smart agro-technology youth network. Through this, we have disseminated and we have built the capacity. And so far, a numbers of people have been, capacity has been developed. Next, please. So I'm at the end of my actually deliberation. I like to thanks and actually acknowledge the contribution of Fit the Future, USAID for the funding, and Kansas State University of the PHL team, and especially like to thank the ADMI Institute who provided us fund, and especially on the leadership of Professor Alex and the former director, Professor Prashanta Kalita. They have actually provided us an unconditional support and collaboration. And that makes the innovation possible and to scale it successfully possible. So I'd like to actually thank them personally. And I like to also thank the ACI Motors, ADI, Department of Agricultural Extension, Jagarani Chakra Foundation, and Bangladesh Agricultural University, so providing the help to complete this work. So thank you so much. Sorry for the actually technical issues. So thank you so much for patience hearing.
Alex, you're muted.
Thank you very much, Professor Alam. We always learn a lot from your experiences and your reflections. I'd like to encourage all the people in the audience today to please continue to use the chat box for questions and comments, and also use the Jamboard to add your reflections. We'll compile them and convene with discussion after our next speaker, who is Dr. Kerry Clark. I became aware of Dr. Clark through interactions with the Soybean Innovation Lab. She's been instrumental in finding ways to address post-harvest issues related to post-harvest issues and technologies related to soybean. And it has been really impressive to see the impact of that work. I will turn it over now to Dr. Kerry Clark. The floor is yours.
Thank you. Maria, you're going to run my slides, I think, right?
Yes, yes, I am just pulling it right up.
Thank you guys all for joining. I've really appreciated the chat box to see where everybody's from too. So it's great that we have people from all over the world joining today. So there is my email address if anybody would like to contact me. Next slide.
Kerry, ready when you are.
I'm seeing a poll. Wait a minute. Wait, did you change the slide?
No, not yet.
Yeah, next slide.
Perfect.
In the majority of farming communities in Africa, crop threshing is done by hand. This is largely because mechanized equipment is too expensive or inaccessible to many farmers. Lack of mechanization slows farming operations, it puts farmers at risk in changing environmental conditions, and it leads to low productivity and profitability. Hand threshing of crops can cause high post-harvest loss, considerable grain breakage and contamination, and low grain quality. It can lead to up to 100% loss of profit for smallholder farmers. Hand threshing is intense human drudgery, which also causes children to lose school days to assist. Next slide. At the Soybean Innovation Lab, our solution to this was locally manufactured multi-crop threshers run by service providers. Our thresher model was designed and built for Africa by Africans and field tested by Soybean Innovation Lab at multiple locations with subsequent modifications based on farmer requests. The mechanized threshers improve productivity and profitability for smallholder farmers. It provides jobs for service providers and improves farm ecosystems. Local fabrication of threshers supports job creation through industrialization. Local manufacturing supports the entire mechanization value chain, including raw materials, fabrication, maintenance and repair, spare parts, and improved user competency. The SIL program has trained over 200 manufacturers in thresher fabrication over a 2-year period. And a little later in my talk, I'm going to talk about 3 of those. Next slide. The SIL thresher is used on a multitude of crops, including maize, millet, sorghum, rice, beans, sunflower, and soybean. The sales price from African manufacturers is driven by the local cost of raw materials and ranges anywhere from $3,500 to $6,500 US. It used to be much cheaper than imports, but inflation, supply chain interruptions, and unfavorable government tax programs have caused that gap to narrow recently. Next slide. The list of users needing threshers is long, and it includes seed companies, grain processors, aggregators, food and feed manufacturers, and poultry growers. These all need clean grain in a timely fashion to support their product supply chains. Additionally, we have service providers, farmer groups, and farmers who need threshers to get crops harvested in a profitable manner. Next slide. The SIL multi-crop thresher is designed to be used by lead farmers and agricultural service providers, as its size and price is too much for individual farmers. Field testing in Ghana and farmer feedback led to the decision to target service providers. U.S. agriculture also used service providers in the infancy of mechanization when farms were small and equipment was more scarce. Service provision has been a proven method of accessing mechanization for smallholders around the world. Service provision is also an excellent way to employ youth in agricultural areas. Next slide. Because hand threshing leads to serious grain quality issues, the multi-crop thresher helps with reduction of post-harvest loss. A serious result of hand threshing is contamination with dirt and stones in the grain, as seen in the photo on the bottom right side here. That photo is a result of a seed cleaner in a food production facility. And the other photos show the clean output of the thresher. Contamination during stick threshing makes local grain less desirable to processors and has been blamed for the collapse of the local market for some grains in certain areas. An example is that most poultry producers in Ghana will import soy for feed rather than buy locally because the local product is highly contaminated with dirt and stones. Next slide. The Soybean Innovation Lab has 3 major scaling partners for the multi-crop thresher. In Ghana, we work with several companies who make small batches of threshers financed through customer down payments. Sayatech, our main commercialization partner, is seeking outside investment and attempting to grow their manufacturing. They have focused on improved quality control, modifications and improvements based on customer experiences, and building their capacity to source raw materials and parts affordably. They fear that rising prices will put them out of business unless they can get investment that will allow them to scale more quickly and reap the benefits of buying directly from raw material manufacturers. Next slide. In Ethiopia, CAMS Engineering is financed by an outside investor who is part of the diaspora and wants to invest in his home country. They manufactured 100 threshers in China, then assembled them in Ethiopia. Taxes were higher on importing raw materials than they were for importing manufactured ag equipment. And the difference was enough to fund the Chinese manufacturing. The Ethiopian assembly created about 10 new jobs. Their business model is to partner with service providers, which is basically a financing plan that spans a 4-year payback and profit sharing period. They're working with SIL and USAID to determine if the payout for financing is enough to bear the financial risks involved. Next slide. In Zambia, we work with Panoply, which sells threshers to grain uptakers who need a fast harvest and high quality grain to support their food and feed operations. They have found they cannot successfully source the amount of soy they need if they continue to rely on farmers who hand thresh. End users of grain are good partners for introducing mechanization because of their dire need for grain and their ability to raise capital to get the needed mechanization in place. We also have a partnership with a food and feed production company in Uganda who financed a thresher fabrication training due to their need for soybean farmers to be more productive and more quickly deliver their harvests. Next slide. To give you an idea of the economics of the threshers, Sayatech in Ghana has shared that they sell the threshers at a 40% margin, giving them a profit of about $1,800 per machine built and sold. They also do service provision with their own machines, charging farmers approximately $1.60 per 100 kilograms of grain threshed. After expenses of $1.20 per 100 kilograms, this provides Sayatech a profit of $14 per hour of threshing. The farmer pays approximately $56 for 3.5 tons of grain threshed, similar to what they would have had to pay for labor for hand threshing. Next slide. So what does the future hold for locally manufactured multi-crop threshers? The industrialization effort is a little bleak because investment and access to capital are lacking. Without investment, economies of scale are harder to reach. Most African governments allow agricultural equipment imports to enter the country tax-free, but they do not allow the same for raw materials for local equipment manufacturers. Additionally, some materials and components are difficult to purchase locally, such as engines and pulleys are nearly non-existent in Ethiopia. Utilization of threshers, however, has a strong future in Africa. Maize threshers are becoming increasingly common, which drives demand. Cell phones and the internet allow people to source things much more easily now, and service providers provide mechanization technologies to smallholder farmers at rates that are feasible for the customer and yet still profitable for the provider. So I thank ADM, Institute for the Prevention of Post-Harvest Loss, who has helped us fund some of the trainings that we've done. So we couldn't have got to where we are now without their help. Thank you.
All right. Thank you very much, Dr. Clark and Professor Alam, and thank you to all of you who've been actively engaging with the Jamboard and the chat box. What I'd like to do now is try to pull together some of the questions that have come in and some of the questions that were developed earlier and have a bit of conversation with Dr. Clark and Professor Alam. So Dr. Clark and Prof. Alam, if you would please unmute. And please, others, Sarah Schwartz and Maria Jones will be actively manning the chat box and alerting me to questions I should pose on your behalf. But to get started, I think both of you alluded to supply chain problems and concerns in development that caused you to adapt technologies and try to fine tune them to the local environment based on those supply issues. But I know that you were both very attentive to the user's concern and the user's perspective to make sure there'd actually be a group of people prepared to buy these pieces of equipment and implement them for impact. I wonder if you could share some of your experience with methods to understand the user's perspective and what you did to find good information about what mattered to the users that others might find useful as they attempt to go through the same process. Dr. Clark, can you talk a bit about that?
Okay, yeah. So we placed threshers in rural areas where farmers were needing threshing services, and then came back and did interviews, spent time with the people, and got their responses. And then we also continue to work with our designers that also, place their models with users, and then, just we're always attentive to what people are saying, what the problems are. Some of those we can fix, some we can't. We've had some people, that say they wish that instead of a beater bar that we're using a different kind of threshing drum. And some of those, we just can't meet those needs because the kind of threshing drum they want would be almost impossible to find parts for in Africa. So, but we spent 2 years testing and listening to farmer feedback before we kind of went, commercial.
And Prof. Alam, can you tell us a little bit about your methods for getting farmer feedback or user feedback?
Thank you, Professor Alex. Actually, in the design phase of the project, we actually try to follow the product lifecycle framework. As you know, in this framework, the very first step is to look at this product value chain. So we actually looking for the dryer value chain. So when we worked with that and we did actually a market survey with the farmers of different areas, where farmers are actually drying paddy as well as the maize and wheat. So we talked with them and we found that at farmers level, there was no dryer at all for drying the paddy or the maize or the grains, especially in the rainy season. So they are dependent on nature. And when we go forward to this value chain, we find that at this, even in the rice mill level, only the automatic and semi-automatic rice mills have their dryer. But the major rice mills and husking mills, there are about 15,500 of them. They do not have actually any dryer. So we concentrated to 2 of these areas. And in our case, those the farmers are always looking for only the 0.5 ton capacity, that is 500 kg capacity. And that's why we actually initially started working, looking for a design of 500 capacity of the dryer. And we actually imported one of these Vietnamese actually prototype, and we have modified for Bangladesh condition. And we switched a Bangladesh farmer as well as the LSPs. Thank you, Alex.
Thank you. Another thing both of you mentioned was the role of public policy. And I think I heard both of you referring to issues of import tariffs, import controls. They can really determine whether technology is affordable or not. This is one of those systems issues in that it's really an economic policy that's well beyond your technology, but can have a great impact on whether the technology is successful or not. Can you share any experience or any strategies for how you manage to engage policy and policymakers to have some effect on that? I know, Professor Alam, you've been successfully engaging with policymakers in terms of the subsidy. Do you have any tips or advice?
Yeah, thank you, Professor Alex. You know that scaling and adopting any agricultural machines at farmers level is really a challenging thing. It's because the initial investment is high for agricultural machines. And in the case of Bangladesh, the most of these farm holdings are very small, and they cannot actually afford to invest a huge amount of money for that. So there is a concern, unless they are sure that returns is ensured by the technology. So initially, from the public sector, there should be a policy to promote the new technology. And it is actually to the farmers level, so the farmers have this confidence to use it. And when they see that the benefits are there and there is a possibility of return of money, so they can go forward. So in our case, actually, we talked to the Ministry of Agriculture with the help of private sector, ACI Motors, and the Department of Agricultural Extension. So the government actually came out with this, the subsidy program. That is now it is 50% to 70% subsidy on given on selected agricultural machinery, that is dairy is one of them. And this Department of Agricultural Extension, they initially actually promoted 184 of these BAU-STR dryer to the farmers group. And now the farmers are becoming actually confident of using that. So initially the public sector program and public sector need to be invested in that. And then in the later on, so the private sector companies will stabilize the whole market system. That will be a good example.
Thank you very much for that. Now it's come to my attention that Isaac Sesi has been able to join us, which is great. Isaac, we're delighted that you're feeling well enough to be here. Can you, I'm not sure I can see you there. Are you able to make the presentation that you hope to make?
Yes. Thank you.
Okay, then if you're willing, let me celebrate that you're well enough to join us. We're delighted to see you here. As I mentioned before, Isaac Sesi is the CEO and head of product development for Sesi Technologies, and he was willing to talk to us today about developing and scaling the GrainMate moisture meter in Ghana and give us that private sector perspective that Prof. Alam just referred to. So Isaac, please, you can share your screen, or if that's problematic, we can have Maria present the slides. Just let us know how you'd like to go.
Okay, I am trying to set up. Can you just give me like a minute? Maybe.
Absolutely, we can continue with other questions if you'd like while you set up.
Okay.
So while Isaac is getting himself situated, let me turn to one more question to Dr. Clark and Professor Alam. And I want to make sure we think about a little bit about the social environment into which these technologies have to fit. And one of the issues that I know you both think about is gender roles and the sensitivity to women's position and women's demands when you're thinking about any of these technologies. So can you share a lesson or two maybe you've learned about engaging women farmers or women entrepreneurs, women middlemen, women middle people in the process of technology development and scaling?
We actually realized that our technology could cause issues for women because our thresher is more profitable for service providers when they do maize because it threshes much more quickly. And they take a percentage of the grain often when they charge the farmer. So because maize is typically a man's crop and not a woman's, that means the the legumes and the things that women are growing, they're not as profitable for the service providers. So we were very worried about that women may actually get left on the side. And so we wanted to see, could women be group owners of threshers? So we worked with the MEDA, the Mennonite Economic Development Association, and a project in Ghana where 20 women's groups were given threshers. And then we basically went in, surveyed to see what happened. These women's groups were already strong groups with leadership and a history where they had been village savings and loan associations. And what we found was that where there are strong leaderships and a good, tight community of the women's group, they were able to successfully be group owners, because we had been told by many people, you can't have group ownership of equipment because nobody will take care of it. But these women were incredibly professional. Some actually held job interviews for who their operator would be. So all of them hired a male operator, and then they dealt with the finances in different ways. Like some the operator just paid them for the use of the machine. Some, the women collected the money and then they paid the operator. So we kind of observed what everybody did and found that they were tremendous group owners of the equipment. So we do encourage that, and we actually have a program in Ethiopia where we've also got 6 women's groups. We're working with Sasakawa Foundation to make sure women are accessing the threshers and that they're in control, not just have access at the whim of the service provider, but that they can actually control a machine.
Thank you for that reflection. Clearly, and this goes back to my experience for 30 years, is that a well-organized women's group can be an exceptionally strong partner and a great mechanism for understanding women's voices and needs. And I know from your nod, Prof. Alam, that's consistent with your experience as well. But I am going to turn it over to Isaac Sesi now. If you're ready, Isaac.
All right. Hi, everyone. I'm sorry for being late. I had a medical emergency. So my name is Isaac Sesi. I'm the founder of Sesi Technologies. We're a startup that is based in Ghana that is looking to make agricultural services and tools affordable and accessible to African farmers. And I'm going to spend a short time just giving you a background of how Sesi Technologies came to be, and then spend more time talking about the approaches we have taken to commercialize the moisture meter and how we have sort of grown out of that to consider what other solutions could be complementary to the grain moisture meter. So I joined the Postharvest Loss Innovation Lab as a research engineer during my national service at the Kwame Nkrumah University of Science and Technology. At the time, some researchers, Dr. Armstrong and some other researchers, had developed a prototype of the grain moisture meter. Just a minute, I'm still trying to pull up my presentation, but I'll keep talking meanwhile. So they had developed a prototype of the grain moisture meter, and they had determined that if it could be commercialized, it would be a great solution to making it easy for farmers to measure the moisture content in their grains, and to be a low cost but effective way to measure moisture content in grains, to replace the rudimentary ways farmers currently try to estimate moisture, such as biting the grain, tossing it, putting it in bottle, adding some salt, all of those rudimentary ways. So I was brought to join the team because of my experience in electrical engineering and designing products. So over the course of a year, I put together a small team. We looked at the prototype that had been developed. We reverse engineered it, and we redesigned it to be more efficient and cost 50% less than the original cost of the prototype. So, after the project was over, after the first phase of the PHLIL program was over, some of the leaders of the PHLIL came to me and they were like, you should probably turn this into a company. Because that would be the way to put these meters in the hands of farmers beyond it being a project. So I reluctantly agreed, and then I set up Sesi Technologies with the purpose of commercializing the moisture meter that had been that we had built, or that we had improved. So, but then I quickly realized that designing a product is very different from commercializing or building like a commercial, like coming up with an innovation is very, very different from scaling and commercializing an innovation. And I realized that very fast because it was like my first experience trying to bring something to market, like an electrical and electronic products to market. We overshot production timelines by like several months. We ordered like about $10,000 worth of components we couldn't use at a point. And for a young company, that is like almost like suicide. And it was a very, very, very different thing. In a project, even if the product is not that top notch, people are forgiving. But if you are selling this, people are less forgiving, especially when they are paying money for it. But then the biggest challenge that we faced in trying to bring the GrainMate moisture meter to market was how do we find a business case that was going to work for smallholder farmers? Because even though we had built this moisture meter that you just insert in a bag of grain and gets the moisture reading, farmers really didn't care that much. I mean, in the hierarchy of needs for a typical smallholder farmer, spending money on a moisture meter is probably the least important thing he wants to do. They recognize the problem, they recognize the solution that we had created, but the willingness to pay was just not there. And so we had to be innovative. We had to figure out other ways to get the meter in the hands of people. And one of the things we tried is to figure out what are these guys concerned about? What do farmers, what concerns farmers? And of course, we have to think about this within the realm of post-harvest management, because that was the space in which we were playing in. So we realized that farmers were concerned about like market access, being able to get good prices for their products. Farmers were concerned about storage. Farmers were concerned about threshing and drying. And so we thought that, well, if we could, and another thing we realized was that when you look at post-harvest losses, especially in grains, it's not, the problems are not isolated. They are all linked together. Like you need to be able to, I mean, threshing goes with drying, which goes with storage. They are all linked, right? So we're like, if we could come up with a suite or a system of solutions that farmers could access at an affordable cost, then we could bundle this meter alongside those solutions that they cared about. So we switched to a new model, which we called Farmer Pack, which is essentially providing farmers with a suite of post-harvest management solutions. So it included training, it included threshing, it's included drying, it included storage. So we were like, you know what, if we enrolled you for our Farmer Pack program, we could help you thresh your grains at a price that was lower than what other people were threshing for. We could help you dry your grains at a price that was lower. We could give you hermetic bags that you would store your grains in for a long time. We could connect you to markets, to people that are willing to pay a good price. But then you need to get the moisture meter. right? And so it's all a package. It comes as a package. So that model proved to be successful because first of all, it's being bundled with things that they care more about. Secondly, we're able to tie in the use case of the moisture meter with other things that they cared about. So it puts the value of the moisture meter in perspective for them. And thirdly, there was most importantly, there was an incentive for the adoption of these technologies, which is the fact that we're going to help them get better prices. Because one of the common questions that kept coming up was, if we buy hermetic bag, if we buy moisture meter, if we dry our grains properly, etc., and then we go on the market and everybody wants to buy our grains for cheap, then what is the benefit for us? So by trying to provide a holistic solution to their post-harvest management needs, we're able to encourage the adoption of the grain moisture meter. Other models we tried included strategic partnerships with other organizations that subsidized the price of the meter for farmers such that they didn't have to pay a lot of money to be able to access a meter. So as you can see, we also introduced hermetic bags, which was like one of the things that resonated with them the most. And then the approach it took, another thing to talk about is the approach we took to convincing them of the efficacy of the solutions. Now, when you're introducing something new to a group of people, like they're skeptical, right? So then how do they know that this works? So we for instance, for hermetic storage, what we did was that we put grains into hermetic bags, and then we're like, you know what, we're testing this grain. As you can see, we've tested the grains with the GrainMate moisture meter. We've stored it in the hermetic bag. We are closing it. We'll come back 3 months. We put a control by the side, which was just one bag of their grains, not tested, just by the side. We come back 3 months later, we open it, and then the one that had been tested with the meter and stored in the hermetic bag, it's clean, just in the same condition as it was when we put it in. And the one that was in their bags was just full of weevils and other insects. So that was a way of convincing them that, hey, you know, this works. So first, they have to know that the technology works or the solution works. And secondly, you have to find a model that is suitable to the people that you're trying to, you're developing that solution for. And one thing we see, which is like the disconnect between academia and industry, is that very often when academics are building solutions, they are not looking at who is going to use this solution, can they pay for this, right? And so then you have like a whole, a lot of amazing solutions that are just lying on the shelves because you can't find a business case or a feasible business model through which this works for the people that you're trying to develop it for. And so basically this was our journey to discovering what people wanted, or discovering what the farmers wanted, and how we tailored the entire business model to really suit in a way that could allow us to deliver this technology. So by the time we're done, this went beyond just trying to sell a moisture meter to farmers, to us identifying that, see, the problem is not just, I mean, if you are just solving moisture testing, you are not really creating a lot of value. But if you can really come up with a holistic solution to the post-harvest management problems they face, then you'll be creating more value, and you'll be at the same time, you'll be creating a model that allows you to deliver these solutions to farmers. Now, these numbers are slightly outdated. Currently, we have like, yes, around 2,000 plus farmers in our network who are receiving the services I mentioned above, hermetic bags, moisture meters, drying, threshing, market access support. They are spread across about 45 FBOs now. We've deployed close to 15,000 hermetic bags now, and then we have sold about 1,500 moisture meters at the moment. And so going forward, the goal is to extend this suite of post-harvest services to more farmers in more communities. And in it, we're able to also tie in the moisture meter and like just put it in as one of the solutions within the suite of solutions. And we've collaborated in the process with the World Food Programme, the Siemens Foundation, obviously the Postharvest Innovation Lab, Royal Academy of Engineering, amplifies. The Soybean Innovation Lab their logo should also be here. So we are a team of about 15 now. That is led by myself, Eunice, Emmanuel, and we're all driven by the desire to really, do something that really benefits, like that has social good. And so if you look at our team, average age of the team is like 24 years, and day in, day out, we are learning new things, and our joy is to see farmers succeed. And by using technology, we know that technology has the potential to really make a lot of change the way a lot of things are done within our agri value chain. So if you want to connect to learn more about what we're doing and how we're doing what we're doing, you can just reach out to me on LinkedIn or by email, and I'll be more than happy to chat. Now, one thing I should
very much,
mention.
Isaac.
Oh, sorry. I see we have just.
Thank you very much. It's exciting to see how your success is leading to the success of this many farmers, and this journey of scaling through commercialization. Your sensitivity to the market system and the needs of all the players is really exemplary for a lot of us. We're coming to the end of our hour, so I'm sorry I have to cut you off, and we're not getting through nearly as many questions in the chat box as I would have liked to have. I want to thank all of you for putting in your questions, and I apologize that we can't bring them to the panel for discussion, but I am sure that if you directly contact any of the speakers with your specific questions about a specific country or technology, they will be happy to get back to you, or we at the ADMI would be happy to connect you appropriately. You have been putting things on the Jamboard. Maria, are there any reflections or synthesis you can give us from what was put up on the Jamboard? Maria Jones?
Yes. So very briefly, I just wanted to share what some people have been posting on the Jamboard. Like for instance, some of the things that have come up are how training and subsidies are required for the farmers to scale adoption of technologies. Looking at other grains, for example, for the dryer, looking at more of the local service provider model, connecting really commercializing technologies, and the group ownership model that Dr. Clark also mentioned about. Many people refer to some new technologies, which I haven't, personally looked into too much, like for example, plastic crates, or like even the metal silos or reversible flatbed dryers. And I think some things that did come about in like advice for entrepreneurs was the need for developing skills and these investing in more of drying and storage technologies. Thank you so much for sharing and for participating in the Jamboard. You should be able to access the Jamboard even after this webinar is done. Thanks, Alex.
Thank you, Maria. And we have come to the end of the hour, I'm afraid, so I do need to bring this to a close. As I do so, I want to first thank the presenters for the work that they do and for taking the time to thoughtfully engage with us today. So Isaac Sesi, Dr. Kerry Clark, Professor Monjurul Alam, please know that we at ADMI are very grateful to you for being here today and for your work. I also want to thank Maria Jones for all the work she's done to bring this together, visible and invisible. And also Shara Swartz, who's been manning the chat box, among other things. So thanks to all in the virtual room who attended today. We really appreciate your input and hope that you found this informative and maybe thought-provoking. I hope also that you'll come to our next webinar. The next webinar in this series is on the importance of capacity building and promoting better post-harvest management. It will be held on February 23rd. We hope to interact with you again at that webinar or perhaps sooner. Until then, best wishes from ADMI and from the University of Illinois.